25, the first part of today is what do you do in a derivative if instead of just x to the fifth is there, you have 3x to the fifth, or coefficient. And anybody have any hypothesis? What will you do with that 3? You just multiply. You do the derivative like normal, and then you multiply. So it's really easy. Unfortunately, I'm a proofy kind of guy, so I'm going to make you prove that. So, or at least prove a case. Would you, just by way of preparation for the test, use the definition of the derivative to find f prime if f is x cubed? Start with the label. F prime is, then the definition. And it's H or delta, just curious what you guys are using. I don't care which one you use. H plus writing. Okay, this makes sense. You can go whatever you want. Get done with f prime, then do g prime off to the side. So, are you getting good practice with the definition of the derivative? So here's I will tell you from experience, the problem on Friday will come that some of you, maybe one or two of you, will have a definition of the derivative problem. And now you have the product rule to check your work. You know what it's supposed to come out. You know it's supposed to come out to 3x squared, and yet some of you have some definition of derivative conceptual error that keeps you from getting there. In that case, then I would say do the algebra accordingly, but then write the note, say, I know the answer is supposed to be 3x squared. I'm not sure what's going on. That tells me, hey, you knew to look, you know what it's supposed to be, and you know you have an error, which is better than not knowing you have an error. Anyway, the first one came out to be 3x squared, as we would expect, and the second one is 6x squared, which came from 2 times 3x squared. So it feels like when we have a coefficient, it's just that coefficient times the derivative on the variable expression. When there's a coefficient, you just multiply it by the derivative of the x function, or the function, I guess I could have just said. That is to say, if you have a constant times a function, just take the derivative of the function up front and multiply it by the constant. Understood? Okay, let's check for understanding. Y equals 7x to the 100. What's y prime? 700x to the 99. Is that easy or what? Okay. Let's go on. Taking the derivative of a sum. Now, let's make sure you understand. The derivative is now another operation in your math vocabulary. All right, operations like verbs, they're actions. So you add, subtract, multiply, divide, square root, sine, cosine, tangent. All those are functions, things you do. The derivative is a thing you do. Some functions, when you do a sum, for example, this, it's tempting to say, is the root of a sum equal to the sum of the roots? Is that true? We know that is not true. Okay, so the root of a sum is not equal to the sum of the roots. Depending on the function, sometimes you can do the function first, then the sum, and some you have to do the sum first, or deal with the sum first. For derivatives, the question is, if you get a function that's a sum of two separate functions, maybe x cubed plus 5x squared, can you just take each guy's derivative individually? Well, that's the hypothesis. Is h prime of x just equal to each guy's derivative? Can you just do each guy's derivative? Now then, this is actually, so the problem with this proof is that you haven't done a lot of limit rules. So you're going to kind of be learning on the fly here. Let's go here, and you don't even know you're going to learn some limit rules, but you're about to learn some limit rules. So here's the deal. Wouldn't you say that the definition of the derivative is the limit as, now in this case, why should I not use h? H is kind of used already here now, so I probably need to go something else. Let's go delta. So that is h of x plus delta x minus h of x over delta x, using the definition of the derivative, but instead of using f's, we're interested in really in what's the derivative of h. So we're using h as the function. So far so good. Just normal derivative, but using h for the name instead of x. Cool? All right, now, it says here that h is really the idea that f of whatever you put in plus g of whatever you put in. So couldn't I replace h of this with f of that plus g of that? And in each of those put in what? O is being put into h. X plus delta x. So that's what I'm going to put into g now. Likewise at the back end, instead of h of x, I'm going to call it f plus g, and what goes into each of those? Just x. Delta x, believe it or not. All right. This goes to limit rules here. When I ask you what's the limit as x goes to 2 of 2x squared plus 3x, what is it? You're either slow at math or confused. Which is it? 14. Okay, there you go. Now, I assume that you first put in 2 to this, and then put in 3 to that, and then add, yeah? That is to say that you really did what's the limit as x goes to 2 of 2x squared, and what's the limit as x goes to 2 of 3x. I know you probably didn't write that. That's what you did mentally. You said, what's each part? And then add. That's a thing. That is allowed. So if I want the limit of all this mumbo jumbo sum, I can switch around the order and do this limit and that limit. Now, if I wanted to do that, then my goal is to say, can I get the derivative of f and can I get the derivative of g? So what would I need to get together to look like the derivative of f? Definition of derivative. What's the definition of f look like? F of x plus delta x minus f of x. Is that doable? Well, sure. There and there. It's just subtraction. I can change the order. That's fine. Yeah. And I can put the g's together. Are you tracking? Now that wasn't even rules of limits. That was just rules of arithmetic. Addition is commutative. I can change the order. Also, let's talk basic mathy skills. Is 2 plus 3 all over 5 equal to 2 over 5 plus 3 over 5? Are those equal? Okay, when you add those two fractions, don't you keep the bottom and add the top? Okay, so are these equal? Yeah, okay. Now, this is kind of kooking you up because it's reverse of what we normally do to add fractions. My point is this: if you have a big fraction, you can split it over two separate denominators. All right, so how would I want to split this? Put the f stuff over a delta x and the g stuff over a delta x. All right, and the last goes to that idea I first talked about. We said that the limit of a sum can be split into the sum of the separate limits. So what's my last step I need to do? Split this up. Instead of one big old limit, I want to split it into two. So that is the limit as delta x goes to 0. F of x plus delta x minus f of x. And then another limit as delta x goes to 0 of g of x plus delta x minus g of x over delta x. Well, by definition of the derivative, the very definition, this is the derivative of f. This is f prime. And by definition, this is the derivative of g. This is g of x. And is this in your notes? Why is that there? I think I cut and pasted it, and then I forgot to change it. So would you put sum rule for derivatives? You said it was the same. You lied to me, Ochoa. Okay, so if, so it's already written for you. So if you get a function that's the sum of two functions, if you want the derivative of it, you can just take each derivative separately. Cool. And is this the next thing? Anything else? Are we cool? Maggie, are we good? All right, right on. Derivative of a constant. Let's talk about this graphically, verbally, and analytically. Let's start graphically. What does f of x equal 3 look like? Horizontal line, yay? With a y-intercept of 3 and 0 slope, so that you could think of it as 0x plus 3 if you like. What is the tangent slope to that bad boy? Tangent slope is flat. If the tangent slope is flat, then the tangent slope is 0. And tangent slope is code for what calculus idea? Derivative. The derivative must equal 0. Okay? The derivative of a constant is 0. Let's think about this verbally or just kind of common sense. The derivative is the rate of change. So what's the rate of change of a constant? Nothing. Constant doesn't change. It doesn't have a rate of change. It doesn't change. Last but not least, let's talk definition of the derivative. Actually, let's do this. Could I not call f of x 3x to the 0th power? Do you agree that x to the 0th is 1? So if I wanted to use the power rule, I could say 3 is the same as 3x to the 0. Well, if I took the derivative on that, 3 stays in front. What's the derivative of x to the 0? 0 comes down, drop it down. Well, what is 3 times 0 times whatever? It is 0. We could do the definition of derivative. Let's just bypass it. Do you understand that the derivative of a constant is 0? Say it. There you go. Well done. Use a little more energy, but I'll get it. All right. What does that say? What does that say? T to the 100? T to the 100. Cool. Okay. Would you crank out... Oh, actually, I need to... yeah. Do 1 through... 5, please. As always, when I give you back my homework, I recommend you don't just look at the score. Look for anything I wrote that might have had a misconception that I corrected there. Oops. Sorry. Violating your privacy. Are we done with the first 5? You want a yes? No? Okay. Sam, what'd you say for the derivative of the first one? T to the 99th, straight up power rule. There you go. And as far as what you just found there, this is the, let's just say it is T to the 99th. I don't want to get into that notation quite yet. Number 2, Andy, what's the derivative of 4?
0.
0. Doesn't matter if it's at 3, I don't care where it is, the rate of change is 0, and it's constant. How about Abby, what's the derivative of f on number 3? Thank you. Okay. How about 4? I recommend sometimes when you get a root or a fraction, you do a rewrite. So by that I mean you might call it x to the half plus 5x squared plus 2. That's just advice to you. I don't grade on that. And definitely as we go on, I don't know how necessary that would be, but for a beginner I feel like that's just a smart starting point. So it looks like a power. That said then, Taya, what'd you say for the derivative? What did you say the derivative of x to the half was? Are these the same for you, by the way? Okay. Yes. Sorry, what's the derivative of x to the half?
Oh, 1/2 x minus 1/2
Oh, sorry, and then plus, what was the rest of it? 10x, I agree. Constant, the derivative of 2 goes away, it's 0. Okay. How about on G? If I rewrote it, I would write it as 2x to the negative first plus x to the 4/3. So when you go to evaluate, you can see that they're not just saying find the derivative, but they're saying find the derivative at 8. That's 2 steps. I require that you write the derivative first, then put in 8. And so notation-wise, you need to show that. So what is the derivative of 2x to the negative first, Martin?
Negative 2 over x squared.
Okay, I agree. And what about the derivative of x to the 4/3, Mr. Lowry?
4x to the 1/3.
4x to the 1/3, 4. You might be right, I need to, 4/3 x to the 1/3, yeah? Okay. 4/3 x to the 1/3. Now, at 8, that's negative 2 over 8 squared plus 4/3 of, oh yeah, okay. X to the 1/3 is the cube root of 8, eh? So did you get something like negative 1 over 32 when that's reduced, plus 8/3? And what is the common denominator? Oh, yeah, I got to be able to do arithmetic? Yeah, you do. Okay, so do you agree the common denominator is 96? So what did you multiply the first one by? 3. What is 8 times 32? Mentally. What's 30 times 8 plus 2 times 8? 240, 256. Okay, so 253 over 96. Yay? That's the slope. Okay, so on number 6, you can see that it's h prime at 1, and I'm doing a little less hand-holding here. So when they ask you to evaluate at a number, I need to see 2 steps. First h prime at x, and then h prime at 1. What'd you get? Negative 1/2. All right. Now, for the most part, the concept will be this easy. But if they give you little kind of yucky ones, they might look something like this. Sometimes, rather than actually giving you a numerical coefficient, they'll give you some kind of unknown coefficients, like in this case, A and B are. It's not a big deal, you'd still do the same kind of thing. So, just so we're clear, what's the variable in this problem? T, okay, now T is what you take the derivative on. A is like a 3 out front, so it's just like a coefficient, so don't even take the derivative on A, don't worry about A, just say it's A times the derivative of T to the 4th, which is 4T cubed. You can leave it like that, or if you like, you can write it as 4AT cubed, either one's fine. Same goes to B, it's B times the derivative of T to the half. So what's the derivative of T to the half? 1/2 T to the negative 1/2. If we subtract 1 from a half, it's the negative 1/2. You could leave it like that again, or you could write it as B over 2 root T. It's important that you can find the derivative, but this kind of playing with it, that'll be necessary in multiple choice problems. You need to be able to say, oh, if I do a little algebra, clean it up, that's my choice. All right, so you need to be able to do that. And then finally, you will have cases where you're expected to do a little algebra work up front before the derivative. This is a product, and there is a rule for taking a derivative of product you don't know yet. So to avoid that, what do I do kind of thing, you unmake it a product and multiply first. So x to the square of x times x. That's x to what power? 3/2 minus x to the 1/2. Why is this out front? Shouldn't that be gone? Why is it out front? I didn't actually take the derivative. I just did a little algebra there. I haven't taken the derivative yet. So now take the derivative. That means take the derivative with respect to x, which will make more sense when you get to implicit. But what is the derivative of x to the 3/2? 3/2 comes down, drop the power by 1, 3/2 x to the half, right? What's the derivative of x to the half? 1/2 comes down, drop the power by 1, and you can leave it like that if you like. All right? Try number 8, looking to do algebra before derivative because you don't know fraction derivatives or quotient rule yet. So do algebra first. Some of you actually don't know quotient rule, but see how you did. Do you agree that I could split the fraction? Pause for a second. We talked about how that is allowed. 3 plus 5 over 2 is equal to 3 over 2 plus 5 over 2. That is true. Yes? Okay. Can a fraction that has a sum in the denominator be split? Is 1 over 2 plus 2 equal to 1 over 2 plus 1 over 2? Can I split a sum when it's in the denominator? Well, that depends on if you think 1/4 is equal to 1. Is it? I don't think so. And so, as far as the mathematical rules for splitting a sum in a fraction, if the sum's in the top, good to go, split it. If the sum's in the bottom, you may not split that. Do not do that, you just broke math. So, in this case, the sum is in the numerator, you may split it, so that's what I did, and then I cleaned it up. So when you take the derivative on 3, Abby, what's the derivative of a constant? 0. And when you take the derivative of t to the negative first, Kelsey, what's the derivative of t to the negative first? Perfect. Okay. All right. You with me, people? Yay. All right. Let's go. Would you get to the homework last night? Did the homework last night go delightfully well? Oh, you got shades too. Cool. All right. So, if you use your notes, then your notes probably confused you for this first one. These are problems that you didn't have answers to, so I'm going to get the replacement answers real quick. And then I'll also go over any book problems you have. question? And we have 17 minutes, so here we go. For this first one, I usually start with the shift. What's the starting value, quote unquote? Pi over 6, because it shifted right pi over 6. Then I do the period to say what a full wavelength is. If the coefficient here changes the period, then is the period 3 times 2 pi or 2 pi divided by 3? 2 pi divided by 3. The end then, if I start at pi over 6, add 4 pi over 6, then where does that end away? Okay, 5 pi over 6. Pi over 6 starting plus 4 pi over 6 traveled puts me at an ending of 5 pi over 6. What's a quarter wave distance? If a full wave is 2 pi over 3, then what's a quarter wave? Or 4 pi, actually, let's go to 4 pi over 6. If a full period is 4 pi over 6, then a quarter wave is pi over 6. With that said, then what's a logical horizontal scale to choose? Pi over 6. Now you could go pi over 6 per box or per 2 boxes. Either way, I think I'm going to go pi over 6 every 2 boxes, so my graph's not too busy. But if you did every box, that's fine too. Vertically speaking, what's the 2, what's the 3? 2 is the center line, and 3 is the amplitude. Okay, so we said the starting point of a positive sine curve is at pi over 6. So doesn't that mean I'm going to be at the center line at pi over 6? And then every quarter wave is another pi over 6. Now based on my scale, I have every 2 boxes as every quarter wave. So quarter wave, 2 boxes, I'm at the max. 2 boxes, I'm at the middle. 2 boxes min, 2 boxes middle. Going backwards, I could also go 2 boxes. That would take me back down to the min. 2 boxes middle, 2 boxes max, 2 boxes middle, 2 boxes min, ending at 2 boxes middle. Boom. So besides a shifted positive sine wave, what else could this be? An unshifted negative cosine. That would be fine and dandy also. All right. Let's go with, so if you did pi over 6 per box, what would your wave look like? A lot tighter, yeah? Okay. So, negative 4 cosine pi x over 8. The starting point is it shifted horizontally at all? No, so it starts at 0, and I'm saying quote unquote start, it doesn't really start or stop anywhere, it's infinite, but period. 2 pi divided by pi over 8 is 16. A full period is 16, not 16 pi, just 16. So it'll start at 0, go 16 units, ending at 16 units. And what's a quarter wave? 4. So do you want to go by 1s, 2s, 4s? Go by 4s? That's going to be so busy. No me gusta. I'm going by 1s. Forget you fools. All right? So negative cosine here. And you know, if you go by 1s, you don't have to say anything. Actually, you can just let go. Is the center line negative 4 or is the center line 0? 0. And the amplitude is 4. So it's going to go up to 4 and down to negative 4. And it starts at 0. Doesn't the starting point of a negative cosine wave, isn't that the min? And if my scale is 1, then I'm going to go every 4 boxes to the next point. So what's that? When I go right 4 boxes, that would take me to the center line at the x-axis. 4 more boxes would take me to the maximum. And at that point, I'm almost off my graph. Going backwards, 4 boxes, center line, 4 boxes, max. Okay, there you go. So, something like that. Doesn't that look lovely? Is your graph a thing of beauty? Hey, Maria Kondo or whatever her name is. Your graph better spark joy in my heart. All right, a common question in college and on the AP test is to estimate a derivative value given a table. The book doesn't really teach this, so we need to throw it in. You'll find that I throw in a lot of little micro concepts along the way. It's on you to pay very close attention to those. And so here we go. A graph isn't necessary, especially the more you do these, but for starting out, I think it might help communicate the point. 1, 2, 3, 5, 6. All right, so I'm given 4 points on the curve, and I have no idea what this graph looks like, other than it's continuous. I should have told you it's continuous. All right, it's continuous, all right? So, my idea is this. F prime at 4 is, what's the tangent slope here? Well, I don't have any clue. It could be this, or the curve could look like this, or the curve could look like this. There's just no way to know. The best I can do is say, well, shoot, I could take these two guys and draw a secant between them and hope that that's a pretty decent estimate of the change at 4. So first thing when you go to do this is you say this is an approximation. On the AP test and in my class, anytime you make an estimate, it must be that. If you say hard equals on an estimate, it's a 1-point question, you get 0. I don't care what your answer is, I don't even look at it. If you say it equals, you're done. Okay? It's an estimate. And don't think about doing some kind of wussy, I'm not sure if it's an estimate, so I'll do it. That makes you more mad. Now you're wrong and practice. Okay, so please be intentional. Say, this is an estimate. I'm going to use the slope between 2 points. And I'm going to use the points as close to 4 as I can. And the whole idea of a limit is get as close as you can to the point of interest. So I got to use 3 and 5 to get close to x at 4. So f at 5 minus f at 3 over 5 minus 3 is an estimate of 4 minus 5 over 2, or negative 1/2. Your answer should be negative 1/2. The rule is you use 2 points as close as possible to the one they asked about, and let that be a stand-in for the slope. So what are 2 points as close as possible to 6? Well, it doesn't get any closer. Yes? Say it again. Just a second. I'm sorry. My ears are bad. Say it again.
So in the, like, first you use the equal sign, but in the second step you use like the derivative.
Okay, good question. That's a great question. You're asking an excellent question. All right. So she asked, 1 second, this is an estimate, but now you're saying equal, hard equal. Now, I say hard equal to because this truly does equal that. It's not an estimate of that. This is that. They're equal. And so that's hard equal. Now, as far as how you would read this mathematically, in terms of a trichotomy, this and this and this is what rules. Okay. This is estimated by this, which is equal to this, therefore this is estimated by that. So it is an estimate still, but as far as these two, that actually equals that. That's why I'm using a really hard equal. Does that make sense? Yeah. Okay. Great question. I didn't even think to talk about that. Thank you. F at 6. What are 2 points as close to 6 as possible? 6 and 5. So if I use 6 and 5, as far as what I'm doing, remember I'm defining slope, which is change in y or change in a function over change in x. So that's 0. Yay? Okay. This problem here. Is this function continuous at x equal to justify with the definition of continuity? This might be good review for the test. The first part for continuity is, does f at 2 exist, or is it defined? Is f at 2 defined? It is defined. They tell you when x is 2, this is what you do. So that's a yes. What does it equal? It equals -4. All right. Now we want to see, all right, what about the limit, the approach around 2? The limit as x goes to 2 of the function. Now, do I need to do left hand, right hand? Or is left hand and right hand both going to be by that guy? Yeah, anywhere that x isn't 2, which includes the left hand and the right hand, is that guy. So I need to take the limit as x goes to 2 of x squared minus 4 over x minus 2. That's 0 over 0, which means graphically there is a hole. I know there's a hole there. The question is, by defining the point at 2 to be negative 4, did they fill the hole? So x minus 2 drops out and you get x plus 2, yeah? And at x plus 2, the y values approach 4. Now that is to say that this graph, if I were to graph it, the curve is approaching, when x approaches, oops, forget I did that. When x approaches 2, y is approaching 4. But the dot they put is when x is 2, y is negative 4. So did they fill the hole? No, they put it in the wrong place. And so we would conclude that f is not continuous. Why? This is where the math is saying it right comes in. Because the limit is not equal to the function at 2. What it approaches and what it is are not one and the same. You with me? Okay. And as far as the evidence to back that up, it's in my work. Negative 4 and 4. I clearly found those and labeled them so they know where I'm coming from. All right. Is f continuous? So what is this streaming? Use the IVT. So first of all, f is continuous. Please don't be saying in your head, well, you already said it. I don't need to say it. Yeah, you do need to say it to show that you know it's a requirement. As far as the betweenness, is there a y value of 0 somewhere guaranteed in here? Which, in what region of x's is 0 going to be guaranteed to happen? In here between 0 and 3, f is going from negative 3 to positive 5, so y must be 0 in there. You with me? Okay, so f is continuous, and f equals 0 is, or can be found, or can be guaranteed between f at 0, which is negative 3, and f at 3, which is positive 5. So by IVT, there must be a place, x equals c, where f at that point equals 0. Use the question. Okay? One more side question. What if I said, how many times must f equal 0? Answer the question. Please. How many times must f equal 0? Oh, somebody said, what? At least once. Would it be appropriate to say once? That would not be okay because you're reading way too much to the table. You have no idea what's happening between those points. It could be passing through 0 100 times. So it would be at least once, not just once. Right? Okay. I have no idea what this means. Oh, it's in the book, right? Did I change it slightly? Maybe I should. Do we need answers to this, or am I wasting your time? Should we go over other questions in the book? You need more? Is there anything else you need more? Like number 1 was hard for some people. Okay, 1 was this. They're taking a sheet piece of metal that's 1 meter wide and 20 meters long and trying to crease it along these dotted lines so that when you fold it up along those dotted lines, it could be a gutter that carries water. So if this is x, then what's the volume of water you could carry in the gutter? Now, first of all, when you fold it up, it's a rectangular prism, yeah? Length is easy. How long is that gutter? I'll call this the length. How long is the gutter? 20. That doesn't affect that. What about the width? Now, the width of the gutter is here, which it would totally depend on how much I made x, yeah? So what is the width of that gutter as a function of what I choose for that x? Yeah, 1 minus 2 x's on either side. So it's going to get shortened up a little. And what's the height? X. Once you make a fold of x and turn it up, it's a. I don't care if you distribute that out. You can leave it like that. Don't waste your time on stuff like that. Just leave it, all right? Is there anything else you would like to talk about? Okay. Let me know if you have other questions. I'll just leave it at that. Cool. I don't feel like I want to put these up. Have a nice day, people. Buenos dias. Okay.